Welcome to this lecture on differentiability of inverse functions by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
So today we will do inverse functions, differentiability of inverse functions. So this is the result that we will use in our this differentiability. So we are not going to write its proof. So what this theorem says is, its name is continuous inverse theorem, and what it says is that if you have a function defined on an interval that is strictly monotone and continuous. Okay, strictly monotone means x1 less than x2 implies fx1 is less than fx2, right? This is, sorry, monotone means it may be greater, less than, or greater than, strictly increasing or strictly decreasing. This one is strictly increasing and another one will be strictly decreasing, right? So monotone means either strictly increasing, or strictly monotone means either strictly increasing or strictly decreasing. So this is strictly increasing, and similarly if we have fx1 greater than fx2, then it will be strictly decreasing, right? So what this theorem says is continuous. What this continuous inverse theorem says is, if you have a strictly monotone and continuous function defined on an interval, then its inverse is also strictly monotone and continuous. Okay, on J. And what should be J? J is equal to Fi. We have done a theorem that continuous image of an interval is an interval. So J has to be an interval. If I is an interval, then Fi is also an interval. So J is an interval. So the function G, which is the inverse of F, is strictly monotone and continuous on J equal to Fi. So J is an interval, right? And what is the definition of inverse function? Yes. What is the definition of inverse function? A function, let f be a function from I to R. Let f be a function from I to R. Okay, then the function G defined on Fi to R is called inverse of f if, yes, what is the definition? If g of fx is equal to x for all x belonging to I, and f of gx is equal to x for all x belonging to Fi. So that means g of f and f of g are identity functions, right? G of f is identity on I and f of g is identity on Fi, right?
Yes, sir.
Okay. So then for differentiability, so now what will be the derivative of this inverse function? That is what we are going to do today. Okay. Differentiation derivative of inverse. Okay, so this is the theorem, derivative of inverse. So what it says is that if you have a function I which is strictly monotone and continuous, and G is the inverse of f, so this we know by this result, continuous inverse theorem, that G will be strictly monotone and continuous in function inverse to f. Now what this theorem says is that if f is differentiable at C and its derivative is non-zero, then our function G will be differentiable at Fc, and its derivative is given by G dash D is equal to 1 by F dash C. Okay. The derivative of G at Fc is given by 1 by F dash C. Is it fine?
Yes, sir.
In simpler words, it means that if f from I to R is strictly monotone continuous function, on I and for C belonging to I, let f be strictly monotone continuous function on I, then if f is differentiable at C belonging to I and f dash C is non-zero, then f inverse is differentiable at f of C and the derivative of f inverse at fc is given by 1 by f dash C. Okay. Simple. Derivative of f inverse at fc is given by 1 by f dash C. Is it fine? Is this statement clear to everyone? So this is the simplest statement. So because ये जो result है ये तो हमारा directly अपने आप ही follow होता है by continuous inverse theorem. So इसको g को इस तरह का लेने की जरूरत नहीं है because g is this function. ठीक है, क्योंकि continuous inverse theorem से यही आता है कि the function g is strictly monotone and continuous on j. So ये condition second वाली condition by default ही आ रही है by this first condition. So इसकी जरूरत नहीं है, second condition की जरूरत नहीं है. Now if f is differentiable at C belonging to I and f dash C is non-zero, then G is differentiable at FC and it is given by this. Fine. ठीक है, is it fine? तो हमें ये चेक करने की जरूरत नहीं है, ये रिजल्ट चेक करने की जरूरत नहीं है ये कंडीशन, क्योंकि ये हमेशा ही होल्ड करेगी because this is there, so this will automatically hold by continuous inverse theorem. So second hypothesis is not necessary because it follows directly from this, so we don't need to keep it here. Fine. So let us try to write its proof. What should be its proof? Yes. So we are given that f is differentiable at C and f dash C is non-zero. We have to show that the inverse G is differentiable at FC and its derivative is given by 1 by f dash C. So अब हमें क्योंकि f जो है C पे differentiable है, we are given f is differentiable at C and f dash C is non-zero. To show G equal to f inverse is differentiable at fc and G dash of fc is equal to 1 by f dash. So ये show करना है हमें. So now because f is differentiable at C, so by Carathéodory theorem what will happen? Yes. So by Carathéodory theorem there exists a function phi from I to R such that first phi is continuous at C, right? Phi will be continuous at C. Second, fx minus fc will be equal to phi x times x minus c, right? For all x belonging to I. And third, yes, what is the third property? Phi of c is equal to f dash c, right? So this is by
Sir, phi
Carathéodory
of x is equals to fx minus fc upon x minus c. डिफरेंशिएबल हो
हाँ,
जाएगा सर.
यही कंडीशन तो है कि fx minus fc equal to phi x times x minus c. ठीक है. So since f is differentiable at C, so we will have by Carathéodory theorem there will exist a function phi from I to R such that phi is continuous at C, fx minus fc equal to phi x times x minus c, and phi c is equal to f dash c. So this implies phi c is non-zero, right? क्योंकि f dash c is non-zero. और non-zero है तो उससे क्या होगा? So since f dash c is non-zero, so this implies phi c is non-zero, and as phi is continuous at c, so there exists delta greater than 0 such that what will happen? Phi x is not equal to 0 for all x belonging to delta neighborhood of c, right? There will exist a delta neighborhood of c in which the function is not 0. अगर continuous function है और उस पे values नॉन जीरो है तो वहां पे हमारे पास एक डेल्टा नेबरहुड आ जाएगा जिसमें function will be non zero, right? This is the result that we have done so many times, right? Is it fine? इंटरसेक्शन आई भी कर दो बिकॉज डोमेन में भी x होना चाहिए हमारा, सो वी डेल्टा सी इंटरसेक्शन आई. ठीक है, इज इट फाइन? Is it clear everyone? Is it clear? अब हमें इनवर्स पे जाना है, सो इसको इसका जो है इमेज ले लेंगे. सो लेट u इक्वल टू f ऑफ v डेल्टा c इंटरसेक्शन i. ओके, सो वी हैव assumed u to be equal to this. Then because this is an interval, so this has to be an interval. U is an interval. ठीक है, u is an interval. ओके, तो अब हमें एक फंक्शन फाइंड करना है. वी हैव टू फाइंड अ फंक्शन. ठीक है, वी हैव टू फाइंड सम फंक्शन which satisfies the property. क्या प्रॉपर्टी सेटिस्फाई करनी चाहिए? gy minus g of fc equal to 1 psi times y minus d, right? बिकॉज हमें एक फंक्शन फाइंड करना है, सो उसके लिए नाउ फॉर एनी y belonging to u consider y minus fc. so y को क्या लिख सकते हो? यस, y को क्या लिख सकते हो इनवर्स के उसमें? f of f inverse y, क्योंकि y is in the domain of f inverse. f of f inverse y minus, अब fc को क्या लिख सकते हैं हम? okay, let it be fc. ठीक है, is it fine? so this is your f of f inverse y minus fc. ठीक है, so now अब ये वाले f inverse y कहाँ पे तुम्हारा बिलोंग करेगा? it will belong to I, right? so ये वाली प्रॉपर्टी हमारी अप्लाई हो जाएगी. fx minus fc is equal to phi x times x minus c, right? fx minus fc is equal to phi x times x minus c. so this is equal to phi of f inverse y, yes, f inverse y minus c. ठीक है, in this property fx minus fc equal to phi x times x minus c using second. ठीक है, so this is your, इसको phi of g लिख दो, phi of gy minus c, since g is equal to f inverse. हमारा g is f inverse है, so ये आ गया अब हमारे पास. yes, what next? तो नाउ देखो ये इस फॉर्म में आ गया ना. c को क्या लिख सकते हैं हम? g of fc, right? so this is phi of gy times gy minus g of fc, right? क्योंकि c is equal to g of fc. ठीक है, अब ये जो ये फॉर्म देखो हमें यही चाहिए थी, g of x minus g of something should be equal to some function times y minus fc. So ये वही चीज आ रही है. So इसको बस हमें इस तरह से लिखना पड़ेगा. This implies g of y minus gfc is equal to 1 by times phi of gy y minus fc. Is it fine? और ये डिवाइड क्यों कर पा रहे हैं हम? y phi of gy 0, क्योंकि gy हमारा कहाँ पे है? gy belongs to this. सो यहाँ ये वाली प्रॉपर्टी से, क्योंकि हमारे जो डोमेन डेल्टा, इसीलिए हमने ये 0 करा था और कोई इंपॉर्टेंस नहीं था इसका. स्टार यूजिंग स्टार. ठीक है. नोट y belonging to u implies gy belongs to v delta c intersection I, and this implies phi of gy is non-zero. Okay, using star. ठीक है. So is non-zero, so we can divide. So इसलिए हम इसको डिवाइड करके लेफ्ट साइड में इस ये जो है हम नीचे ले आए यहाँ पे. ठीक है. we have divided it. Okay, so we have brought it in this side. So ये डिनोमिनेटर में इसलिए ला पाए because this is non-zero. और non-zero क्यों है? क्योंकि y हमारा u के अंदर है, और u के अंदर आने से क्या हो रहा है कि gy जो है ये अपना non-zero आ रहा है. ये phi of gy is coming out to be non-zero because gy belongs to this and phi is non-zero on this interval, right? So hence let psi of y equal to 1 by phi of gy 1 by phi of gy for all y belonging to u. ठीक है. So then gy minus gd is equal to psi y times y minus d for all y belonging to u where d is equal to fc. ठीक है. So d is equal to fc. So hence our function, because this satisfies this characteristic property, right, that we are able to find a continuous function. Xi is continuous because phi by algebra of continuity ये जो continuous है, psi is continuous. Since composition of two continuous function is continuous, right? So by algebra of continuity, psi is continuous at, कहाँ पे continuous होगा? At d, right, this point d. So hence by characteristic theorem, okay, we are able to find a continuous function which satisfies this property. So by characteristic theorem, g is differentiable at fc, which is d equal to fc, and g dash d is equal to psi of d, right? And psi of d is 1 by phi of gd. So this is 1 by phi of g fc, right? So this is 1 by phi g of fc. So this is 1 by phi c, and phi c is your f dash c. So hence g dash d is equal to f dash c. Hence proved. Is it fine?
Yes, sir.
Yes, sir.
Okay, fine. So what we have done is, let me just give an outline of the proof again. So what we have done is, we were given a strictly monotone continuous function on an interval I, and we were also given that the function is differentiable at point C and f dash A is non-zero. So what we have done is, we have used because f is differentiable at C, so we have used this characteristic theorem to get this to get a function phi which satisfies these three properties, that the function is continuous at c, fx minus fc is equal to phi x times x minus c, and phi of c is equal to f dash c. Now what we have done is, because phi c is equal to f dash c and f dash c is non-zero, so phi c is non-zero, and phi c being non-zero with continuity, it implies that we are able to find some in delta neighborhood of c such that the function is not differentiable at that point. Now we take the image of this set, this delta neighborhood of c, image of that under f, so we call it as u. Now then for any y belonging to u, we start with y minus fc. Then we use this property of inverse function, that y can be written as f of f inverse y, right? Y is equal to f of f inverse y. So that's why I've used g. अगर मैं g apply करता तो it may have confused you. That's why I have written f inverse first. So f of f inverse y minus fc. So this, now I have brought it in this form, f of f inverse y minus fc. So this is f of x minus fc form, right? This second form, f of x minus fc. So then we have applied this property, so we got this phi here, and then we have replaced f inverse by g because g is equal to f inverse. So we have got this. So now, because this is non-zero, why it is non-zero? Because y belongs to u, and y belonging to u implies our gy belongs to delta neighborhood of c, and phi is non-zero on the delta neighborhood of c. So this is non-zero. Okay, we have given the proof also here that it is non-zero, so we can write it, we can bring it in the denominator, and then we take psi to be the function 1 by phi of g on the interval u. Then our gy minus gd is nothing but psi of y into y minus t. So this psi satisfies the property of Carathéodory theorem, hypothesis of Carathéodory theorem. So by the theorem, g is differentiable at d, and g dash d is equal to psi d, and psi d is nothing but, it comes out to be equal to 1 by f dash c. So this completes the proof of our derivative of inverse theorem. Okay, derivative of inverse theorem. Okay, we give it a name so that we can recall it anytime. So derivative of inverse theorem says that if f is differentiable at c and f dash c is non-zero, then our function g is differentiable at c, and g dash d is given by 1 by f dash d. It is important to note that we take the function f to be strictly monotone and continuous on I. Okay, because we have used the continuity here, we have used the continuity of g. G continuous तभी होगा जब f is strictly monotone and continuous, and here because we are using composition of two continuous function, so phi of g को continuous बोलने के लिए हमें g continuous चाहिए, और g की continuity आ रही है because f is strictly monotone and continuous. by continuous inverse theorem से g की continuity आ रही है हमारे पास. Okay, is it fine? Okay. So what if we drop f dash c non-zero? Because we have seen, we have used, in fact in the proof also we have used f dash c non-zero. So what happens if we drop f dash c equal to non-zero? Remark, we cannot drop the hypothesis f dash c not equal to 0. For example, for the function fx equal to x cube for all x belonging to R. Yes, but it is inverse, it is strictly monotone. Yes, note that f is strictly monotone and continuous on R, right? It is strictly monotone and continuous on R. What about its inverse function? The inverse function g of f is given by G will also be, क्योंकि इसकी कोडो इसका जो रेंज है it also comes out to be equal to in R, so it's a function from R to R again as gx क्या आएगा? Yes, x to the power 1/3 for all x belonging to R. Then clearly, ठीक है, so this is the inverse function. What about differentiability of g at x equal to 0? The function g is not differentiable at f of 0, which is equal to 0, right? ठीक है, is it fine? So f is differentiable at 0, but g is not differentiable at 0. Note that here f is differentiable at 0 and f dash 0 is 0. Okay, so f dash 0 is 0, so that's why we have dropped the condition of this being non-zero, so we are able to find out, so then our g is not differentiable at f0, right? Yes, so we cannot drop the hypothesis f dash c not equal to 0. So अगर ये drop कर दिया तो function may, the inverse may or may not be differentiable at that point. Okay, so इसी का extension है. अब एक point पे differentiability की जगह अगर if we have differentiability on the whole interval, ठीक है, so this is just the same theorem, बस इसमें यहाँ पे क्या है, instead of f being differentiable on at point c, so यहाँ पे f is differentiable on I, then we will say that g is differentiable on j. J क्या है, j is equal to f of I, okay, and g dash is equal to 1 by f dash of g. So I is an interval, f is a strictly monotone function on I, and j is the image of f under I, right? Then g is the inverse, and g is the inverse of f. Then f is differentiable on I implies, and f dash x is non-zero for all x belonging to I. Then g is differentiable on j, and g dash is equal to 1 by f dash. So proof. So we have to show g is differentiable on j, and g dash is equal to 1 by f dash of g. So given f is strictly monotone on I, ठीक है, एक ये दिया हुआ है. Then second we are given that f is differentiable on I and f dash x is non-zero for all x belonging to I. Third, j is equal to f of I. To show g is differentiable on j and g dash is equal to 1 by f dash of g. So for this, अब g को differentiable on j show करना है, तो we will pick any arbitrary point in j. So let d belonging to j be any point. So then there exists c belonging to I such that d is equal to f of c, right? Yes. Acha, so d is equal to f of c. Okay, now as f is differentiable on I, so this implies f is continuous on I, right? Differentiability implies continuity. So f is strictly monotone and continuous function on I. So this implies by continuous inverse theorem, g is strictly monotone and continuous function on j. Is it fine? J is strictly monotone and continuous function on j. So अब देखो, अब हमारी ये सारी प्रॉपर्टी सेटिस्फाई हो रही है इस थ्योरम की एट पॉइंट सी. So then by derivative of inverse theorem, inverse theorem, G is differentiable at D equal to FC and G dash of D is equal to 1 by F dash C, and C can be written as 1 by F dash of G of FC, right? Because G of FC is equal to C. So since G of FC is equal to C, so this implies it can be written as 1 by F dash of G FC, that is 1 by F dash of GD, क्योंकि D के terms में लाना है हमें. So G dash D is equal to 1 by F dash D. So since D belonging to J is arbitrary, it follows that G is differentiable on J and G dash X is equal to 1 by F dash of Gx for all X belonging to. Is it fine? So हमने लास्ट थ्योरम और उसका यूज कर लिया. सो बेसिकली हमने कंटिन्यूटी इनवर्स थ्योरम और उसको, क्योंकि यहाँ पे स्ट्रिक्टली मोनोटोन दिया था, खाली कंटिन्यूटी नहीं दी थी, बट क्योंकि f डिफरेंशिएबल दिया हुआ है तो कंटिन्यूअस अपने आप आ गया. उसकी कंटिन्यूटी से g की वो आ गई और अपने आप ही ये रिजल्ट आ गया हमारे पास. इज इट फाइन?
Yes, sir.
Yes, sir.
Okay, fine. So let us do some examples based on this. So example, for the function fx equal to x to the power 5 plus 4x plus cube for all x belonging to R, show that the inverse function g of f is differentiable at every point in the domain okay, and also find the value of the derivative at also find g dash of 8, because we have to find g dash of 8. Solution. So you have to show that g is differentiable at every point in the domain and you also have to find g dash. Okay, अब ये fx जो है ये फंक्शन है, इसका इनवर्स वैसे निकालना टफ है हमारे पास, लेकिन हमें इनवर्स निकालना नहीं है, हमें तो बस ये शो करना है कि दैट इज डिफरेंशिएबल एंड वी हैव टू फाइंड द वैल्यू ऑफ द डेरिवेटिव एट 8. ठीक है, at the point 8. So how we will do this? So first we will show that this function satisfies the hypothesis of our the last theorem. Okay, so first we have to show that this is strictly monotone and continuous. So why it will be strictly monotone?
Increasing function sum.
Yes, f dash x जो है strictly positive आना चाहिए. So fx is equal to x to the power 5 plus 4x plus 8. So this implies f dash x is equal to 5x to the power 4 plus 4, right? So this is 5. Okay, so this is greater than equal to 4 always, because this is even power of x, so this can never be negative. So because this can never be negative, so this is strictly greater than equal to 4, which is strictly greater than 0. So hence f is strictly increasing and continuous function on R, right? It is strictly increasing and continuous function on R. Also f dash x is never 0. ठीक है, ये कभी 0 हो ही नहीं सकता. Is never 0, या इसको ये लिख सकते हैं f dash x is not equal to 0 for all x in R. Hence, by derivative of inverse theorem, derivative of inverse function theorem, g is differentiable at every point. Yeah, g is differentiable on f of r. ठीक है, on f of r, that is यही डोमेन होगा इसका g का, and g dash is equal to 1 by f dash of g. ठीक है, is it fine? Yes.
Yes, sir.
अब क्या करना है हमें? Now we have to find this g dash of 8. ठीक है, so basically this is our f of c, right? So g dash or g dash is equal to 1 by g dash d is या इसको यही रहने दो, let it be. Okay, now to find f, हमें g dash 8 निकालना है, so we have to, so our d, basically d is 8, so कौन सी वैल्यू पे 8 आएगा, f की c निकालना है हमें, so c क्या होगा, वो वैल्यू ऑफ x at which the function f takes the value 8. ठीक है, so c निकालना है हमें such that f of c is equal to 8, तो c क्या होगा, yes, now g dash 8 is equal to 1 by f dash of g8, right, using star. अब बताओ 8 कौन सी वैल्यू पे आ रहा है f की, यहाँ से 8 f की कौन सी वैल्यू पे 8 आ रहा है, कौन से x की वैल्यू पे f 8 वैल्यू लेगा, x को क्या पुट करेंगे,
0.
0.
yes, 0. So this is 1 by f dash of g of f of 0. ठीक है, this is 1 by f dash of 0 because g of f of 0 is 0. So this is equal to 1 by f dash 0 is, अब f dash 0 क्या आएगा अपना, फाइन. अच्छा यहाँ पे 3 दिया हुआ था, ठीक है, लेट अस मेक इट 8, क्योंकि यहाँ पे हमने 8 लिख दिया, उधर 3 लिख दिया, और इसीलिए ओके. This is how you can find, so you have to find f of 0 equal to 8 since f of 0 is equal to 8. ठीक है, तो हमें ये वैल्यू फाइंड करनी पड़ेगी, क्योंकि हमें ये g को हटाना है, क्योंकि g हमें पता नहीं है, हमने g निकाला नहीं है, we have not found the g inverse. Finding inverse of this is difficult, so what we have done is we have not found the inverse of g, but we are able to find the value of its derivative through our this derivative inverse function, क्योंकि g dash depends on f dash और f dash हमें पता है, right? So अब हमें ये g को रिमूव करना है, तो g को हम इस तरह से रिमूव कर सकते हैं कि we can find the value of this, कि कौन सी वैल्यू पे ये 8 आ रहा है, so it is coming out at 0, so that's how we have removed this. Okay, is it fine? Okay, let us take another function. Let us take another example or question. So same question ही लेना होगा, but we will change the function, okay, and some values. So let us just copy this. For the function fx equal to, so this function we will change. So we are taking x cube plus 2x plus 1 for all show that the inverse function f inverse of f is differentiable on f of r. Also find f inverse of 1, f inverse of and f inverse of say -1 -1 आएगा ये किसी पे, अगर इसमें हमने -1 लिया तो दिस इज -1 -2 ठीक है. f inverse of 1 4 and -2. yes, so all these values we have to find. चलो बताओ इसका solution. yes, first what we have to show, since
Monotone and continuous.
f is a polynomial, so it is continuous and differentiable everywhere on R. ठीक है, ये भी लाइन लिख देना पिछले वाले में भी, क्योंकि डेरिवेटिव निकालने से पहले f being a polynomial it is continuous and differentiable on R. ठीक है, ये इंपॉर्टेंट है, ये लाइन ऐड कर देना, और वो हमने एज्यूम कर लिया था, बट इट इज इंपॉर्टेंट. सो इट इज कंटिन्यूअस एंड डिफरेंशिएबल एवरीवेयर ऑन आर. नाउ f dash x क्या होगा तुम्हारा, इट इज 3x square plus 2, right, which is greater than equal to 2, which is greater than 0. So since f dash is positive, since f dash x is greater than 0 for all x in R, so this implies f is strictly increasing function on R. Hence f is strictly monotone and a continuous function on R. Also f dash x is not equal to 0 for every x in R. So by derivative of inverse function theorem, f inverse is differentiable on f of R, and f inverse dash is equal to 1 by f dash of f inverse, right? yes. अब हमें f inverse of 1 निकालना है. so now f inverse of dash 1, f inverse dash 1 ही निकालना है ना, dash लगा दो इधर, सारे डेरिवेटिव आएंगे. ठीक है, we have to find the derivatives at this point. so f inverse dash 1 is equal to 1 by f dash of f inverse 1, right, which is equal to, अब 1 कौन सी वैल्यू पाएगा,
0 पे.
yes, it is coming out at 0. so this is your f of 0. so f inverse of f of 0 is 1 by f dash 0. and what is f dash 0? f dash x is this, so f dash 0 is 2.
2.
1 by 2. now अब दूसरी क्या निकालनी है, f inverse dash 4. f inverse dash 4 is equal to 1 by f dash of f inverse 4, which is equal to 1 by f dash of f inverse f. कौन सी वैल्यू पे 4 लेगा ये? At what value it will come out to be equal to 4? At x equal to 1. So क्योंकि 1 plus 2 plus 1 4. So f of 1. So this is your 1 by f dash of 1. And what is f dash of 1? If you look at here, it comes out to be equal to 3 plus 2 5. 1 by 5. Now f inverse dash minus 2. So this is f of f dash of f inverse minus 2. So this is 1 by f dash of f inverse f of कौन सी वैल्यू पे 2 आएगा? minus 2. So when you take minus 1, x equal to minus 1, so minus 1 minus 2 minus 3 plus 1 is minus 2. So it's coming out at minus 1. So this is your 1 by f dash of minus 1, and when you will put minus 1 here, then again you will get 1 by 5. Okay, so this is how you can find the values. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, so this much is enough for today. In the next class also we will do some examples based on this, and then we will solve some exercise problems. Okay, so bye everyone, have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.